Looks like we have JYG. One of the other people, MT Wong, was here a bit ago, but he dropped
Yeah.
off.
But it looks like we're ready to move to the database performance one. So Luke, are you able to hear us all right?
Hi. Can you hear me?
Yes.
Yeah.
Okay. So by the way, we are waiting for Luke to come. He just finished coming from another meeting. Okay, probably another one or
No problem.
Okay. Yes, he's in now.
Okay.
Great.
Okay.
No problem. We can wait a minute. That's fine.
Sorry guys, I was
I'm
caught
gonna
in a
grab some water.
EMC. So, okay, thanks guys for giving us a chance to talk about our idea. The blueprint that we put up basically is to kind of look at, can we get databases and whatnot to run on RBD specifically. And I think a lot of us probably will be aware that a lot of discussion has been put up in the mailing list this couple of days and weeks. I think one of the things we hope to achieve out of this blueprint is maybe a set of documents or best practices kind of work here, where different kind of databases can have different set of documents on what and what not to do, tuning kind of work, benchmark, and so forth. So generally, that's what we are trying to hope to achieve out of this particular blueprint. And obviously, one of the hidden agenda, the ultimate goal, is to see how we can leverage on Ceph capability to run a database on a really, really wide area network, rather than maybe using multi-site to do replications. Can we just do it in just a one single cluster, covering the whole wide area network, for example? So that's the goal. I know it's quite, but that's the point of why we put up this particular blueprint.
Cool. So you said you're just talking a little bit about possibly testing over wide area networks as well as LANs. I think it might be good just to get a kind of a baseline for a lot of different workloads and see where things are at.
Yeah, basically that's yep. Sorry, our network. Yeah. Okay. Sorry. Yes, basically that's what we would like to kind of look at. But I think the first step we are trying to do right now is just to try to understand how database behave and how it affects, for example, in a virtual environment with RBD on top of it, underneath it. So I think we recently actually done some benchmark with Postgres in our little testbed that we have, and we found that the performance is not really what we are expecting. And obviously, because we don't have the luxury of having SSDs and whatnot, we are just doing it on a SATA drive for our OSD. So what we really hope moving forward is are there any other people within this community that are willing to maybe share experiences and best practices to look at, not just Postgres that we are looking at, but MySQL, NoSQL style other works. So so obviously, once we have some of these things tied down, then maybe we can move forward towards some use case for wide area network as well. So I think our first step is at least to figure out what works and what doesn't work, and what needs to be done.
Mm-hmm.
Yes. Yeah, I think the database performance is going to be interesting because in my limited understanding of what the databases are usually doing, they usually have a journal file where they have like a stream of small writes that they're f-syncing, or using direct IO to lay down. And in those, for that like, you know, high op rate of small writes, those are with the general striping strategy, those are going to pile up on a single object, which could potentially be a problem, at least for high performance databases. This is one of the reasons why we added the fancy striping, so you can sort of spread those out across, shard that up across a lot of objects. On the other hand, you don't want to do that for the full image, because it'll tend to amplify your writes when they span stripe boundaries.
Mm-hmm.
So I know that, or I assume that, like, big databases like Oracle and so forth will let you specify a separate device for the database journal from all the other data. Or at least that's my assumption. Actually don't know if that's true, but I assume that they do that. I don't know that Postgres and MySQL do that at all, though, since they're sort of designed to run on traditional file systems.
Well, I'm not sure how much of an issue that's actually going to be for spanning multiple objects, just because the kernel will break up larger requests into much smaller requests in any case. So I'm not sure how large the requests can actually be.
Right. Well, I'm thinking, yeah. I think for sort of mid-size small databases, it's not going to make a big difference in any case. Like having the journal, pound on one object for a while and then pound on the next object for a while, is not going to be too limiting. Especially since it's pure writes, you're not doing any reads. I think for high performance databases, then it could be problematic, and you'd want to do like very carefully choose your stripe size and probably configure your database to lay out its journal events aligned to that stripe width and so forth. But I don't know if Postgres or MySQL will do that. But that's probably,
okay. So
I don't know.
With that in mind, yeah. So with that in mind, does Ingtang or any other guys out there may have done some similar work that may be helpful for some of us here to work on and maybe come up with some packages or work packages or whatnot?
Packages? What kind of packages? What kind of work?
I mean, like some kind of not work packages, but more like what kind of things that we can work on, items that we can work on in sequence that maybe we can kind of feedback to the community and say, okay, hi guys, we have done something like that. I think this is a kind of a good best practices that you can start off with, and maybe you can get more discussion rolling later on.
Deck is in the chat here is saying that they've been running Postgres infrastructure on RBD, and they're happy to help in trying to improve that. And also that you get Postgres actually can put the journal on a separate mount point.
Oh, interesting.
Okay. We did some tests on running MongoDB on RBD, but had not so much luck. Performance was really bad, especially since MongoDB can be configured to run multiple shards on different VMs and Ceph replicating. So you run into problems like have multiple VMs writing to the same pool. So you get with replica level 3, for example, the data written 9 times or something like that, and that's not really performant.
Yeah.
So you need to split these over different pools and make sure the pools are not hitting the same hardware. So and for testing, we did run the database directly on real hardware and trace the stuff with the block tools and replayed it on the VM to see what the difference really is between real hardware and RBDs. That's maybe in test case you can run to see the performance differences.
I wonder if the way to sort of focus in on what the specific issues are and how to best address them. We can get people to focus on like one particular database, and then do a series of experiments to narrow down exactly what what we can do to improve it, whether it's the latency on the write-ahead log, for example. So I mean, one thought off the top of my head would be that if Postgres lets you put the write-ahead log on a different device, try putting just the write-ahead log on RBD and see what the effect is, or put the database on RBD but put the write-ahead log on a local disk, and figure out whether it's the log that's latency sensitive, which is what I'm guessing, or whether it's the background activity on the rest of the file system that's the problem, or mostly at least. And then we can figure out whether maybe the solution is that when you want good database performance, you have two pools in Rados where one of them's backed by disk, one of them's backed by pure flash, and you create a series of small RBD devices on pure flash just for the logs, and then you do the rest of the database elsewhere, something like that.
Or maybe you enable RBD caching, and the cache can coalesce those journal writes.
Yeah, yeah. Maybe it's simple like that, right?
It's issuing barriers, right?
Could you say that again, Sam?
If it's journaling in the first place, it's probably issuing an annoyingly large number of barriers.
Probably at least on the journal. Yes.
Yes, specifically on the journal.
Oh, Deck is saying more things in the chat. Apparently, it's not just the log, since they have synchronous commit turned off, so it's not actually waiting for the fsync, but it's still slow, especially when there are backfills or other failures.
Oh, yeah. Well, that's the one where we have to perform writes to degraded objects. That's what's going on with that one.
So there was a this is sort of a side discussion, but while we're talking about Postgres, there was a long discussion at the Linux Storage and File System Summit like 3 months ago about Postgres performance in general on just Linux, where they described in detail what the issues were. And it basically comes down to they want, if I'm remembering correctly, they want fast synchronous writes to the journal. And then they have all their other table files that they're sort of writing out asynchronously in the background. But at some point, they need them to be durable. And the only way they can do that is via fsync. And they have this problem where they have to tell the kernel to fsync, and that shows a whole bunch of dirty pages down to the IO queues, and then slows down their write-ahead log, which even though they don't actually care when it's durable, they just need to know that it is durable, whatever. So there's this whole... So I think Postgres struggles in general, just because the kernel isn't sort of exposing the right type of interfaces for it.
That's very analogous to the issue we have in the file store, right?
I know, exactly. It was a very interesting discussion.
Okay.
Yep. Yeah, I was trying to dig up the link here, but I'm failing at the moment. There should be a LWN coverage somewhere.
Oops. Okay.
Sorry, Luke, you're breaking up.
Yeah. Our network seems to have been some problem the last couple of days. Speaking of some tools, are there any suggested tools that maybe we can kind of use or agree on when we start doing some more tests or benchmarks?
This I don't know. You're talking about just like standard benchmarks or something that we can use as
I mean, when we're running benchmarks, some of the times we really don't know what kind of tools we can actually further look at to figure out. We have the benchmark tools which we are using right now, but we don't really know what other tools we can actually use for tracing, for example, or figure out what is being done at what level. but we just doing pure benchmarks, So we are just getting numbers, but we don't know really what happened behind it. So is there any suggestion what kind of things we can look at?
Yeah, so maybe we can just make a list in the Etherpad. I mean, the things to check are like, is librd caching enabled? That's RBD cache equals true. We could try reducing.
I was going to say.
I think this is why you're. Go ahead.
I was going to say, are you looking for statistics information, for example, ratios of size of writes going into the to RBD versus writes coming out of RBD, into the Rados, that kind of thing, so you can see what the cache is doing, or are you asking about insight into the RBD configuration?
Well, I think more than just RBD, but possibly also maybe we can look at things happening within the VM, for example, like what is Postgres doing and what not, from both levels, I guess.
Yeah, so inside the VM, they could use tools like blocktrace to see like exactly where Postgres or MySQL or whatever database is writing to the block device. That's probably going through another level of the file system as well. But that'll give you some idea of, and you can use as another tool called Sequatcher, which you can use to visualize what kinds of patterns are going out to disk, which can be interesting. If you see like the journal being written over and over again, and or random writes going on in other areas.
Okay.
How about adding more OSDs? Does that will improve the performance of database running on RBD?
Yes and no. The absolute latency of a single I/O probably won't change much. But if you have lots of I/Os that are contending for the same disks, then they'll be spread out, and so you'll get sort of the minimum latency on all requests instead of having some be slower. So my guess is that the thing that's really slowing us down is just the lower bound on the latency of a write is higher than on a local disk, because we're going over the network and we're replicating to multiple nodes, and then those are all going to disk. So I think it's the thing I'm most interested in is figuring out how to quantify how much of it is that and how much of it might be something else. Like maybe it's the barriers. It's periodically doing a flush, and we have a whole bunch of dirty data, and that's the thing that's slowing it down. Like it's kind of hard to say. I wonder, actually, Sam or Josh, I wonder if doing like a debug MS1 type trace at RBD might be good enough too, just to get a sense of like what the write sizes are and what the latencies are.
Yeah, we could get things like 99-95% latency. That would alone be pretty valuable.
Yeah, that'd be pretty useful. I mean, you need to be some post-processing to analyze that, but that's not too hard. It might also be useful to get like debug RBD equals 20 to just see when flushes happen, how often we're actually seeing them, if we're investigating the cache behavior.
Sorry, what was the second thing, Josh?
Like debug RBD equals 20 to see like when flushes are happening.
Oh yeah. Is there a debug level lower than 20? Just like 10 maybe.
I don't think so.
No, okay.
But it'll basically log each write and read other operations when they begin.
Okay.
Okay.
One more thing. How about other parameters instead of we now planning for things to experiment with, something like RBD, the hardware as well, like in this case maybe SSDs, right? How about other parameters like network parameters, for example, kernel parameters?
Kernel parameters.
I'm not sure if that's really helping. So if you already get the full performance over the network, I would wonder if it helps to tune the kernel network parameters there. So.
Yeah.
I mean, we played around with that, but it didn't help anything. So.
Yeah.
Except the usual problems maybe with 10G or something like that. But if you get the full performance over the network, then I wouldn't expect anything, except maybe stuff that is caused by the virtualization layer in general, maybe. So you can run in trouble and don't get the full performance there, so maybe you have issues there, but except that I wouldn't expect tuning the kernel parameters would help.
Mm-hmm.
Okay.
Is there anything that we can do because no, go ahead.
Sorry.
Oh, I'm just wondering because the OSDs are formatted. In our case, our OSD are formatted with SFS. Is there anything that we can do along the line, like different kind of mount options for those OSDs?
Yeah, you can tune it a little bit, but it's But that ends then more in a general question about Ceph performance at this point. So. Yeah, you can tune your hardware,
I wouldn't expect
maybe,
that's
but
going to be.
That's a general question.
Yeah.
So.
Yeah, I'm not sure that's like the dominating issue here.
Yeah.
No.
I imagine it's more in the sort of the RBD and Rados behaviors.
Mm-hmm.
And just the general desire to make IOs faster, obviously. But.
Okay.
I guess
I mean, in the pad.
The real question for me is, what are your expectations for the performance of the database compared to real hardware? That's the question. Do you expect to show the same performance, or can you live with 50% or something like that? What are the expectations for you?
At this stage, we have not set a goal for the expectation yet, but what we do hope is if we can get something that is close to performance like running Postgres on a local drive, that would be a good start for us. At least if you can see something along that line, then we can move forward and see, okay, guys, now we think we have something that is very close to running on a local drive, or at least a local SATA drive. Nothing fancy, but then we can start to see what else can we do and make it better than just a local drive. Things like that.
Yep.
So we are keeping our goal quite low at this moment of time.
Yeah, and I think that aligns pretty closely with what most people are expecting when they want to deploy databases in VMs.
Is that even possible? I mean, if you put also the network layer and the replication in place, then I would expect it.
I mean, it depends on if your OSDs are backed by something faster than drives, then yeah.
Yeah, but if you have SATA drives in place, then I wouldn't expect to be faster, or at least the same fast than a local drive.
I mean, in theory, there are some things that we can do, right? Because we can reorder writes. So when you're writing to a local disk, then you have to write to the offset that the file system says. Whereas if you're writing into an object store, we can just lay out all objects like sort of sequentially on disk, regardless of what their semantic location is. So in theory, we can do okay. Like we can get someone there, sort of pay for it later on writes or on reads, but for writes at least. But yeah, there's definitely a handicap because we're replicating and we're over the network. and we have a couple layers of stuff in between. I think the hope is that when you have like the Ceph OSD journal on SSDs, that should be helping give you faster turnaround on the writes, assuming you're not saturating your disks. So you can do okay. What can I ask on the Ceph cluster that you're running on? Were you using just hard drives, or were you using SSDs for journals?
We are just using SATA drives. Yeah, for both the data and journal. So we haven't looked at using SSD yet. But I think one of the ideas later on is maybe we can separate the journal and the data away first. And once we have a bit of budget for the projects, we hope to get some SSD in as well.
So that will tend to help. Definitely using SSDs for the right journals, because putting the journals on the disk is hard on the disks.
Do you use a RAID controller in between the disks, or is it pure disk?
Controller, yes, we have controller as well.
Does the RAID controller cache?
Our disk does go through a RAID controller, but we don't actually RAID our disk per se. It's just a pass-through. So I'm not sure what effect the controller will have on the performance. Okay. If that's the question you are referring to.
Yeah, we ran some of our clusters also with JBot and switched over from JBot to RAID 0 with write-back caching enabled on the RAID controller. And the RAID controller has, I guess, an gig of RAM or something like that, and that's improving the performance for us at least by a factor of 4 or something.
Okay.
So if you don't have SSDs, maybe it helps to use the enable write-back on the RAID controller cache, if you have a cache on the RAID controller. Yeah, battery backup, yeah, for sure.
Okay. Cool.
So I mean, I guess I think we have in the Etherpad we have a whole list of things to sort of experiment with.
Okay.
I think you should definitely follow up this discussion on the email list.
Sure.
You know, describe what the test was, and we can suggest, you know, what the next thing to try might be, and seeing what effect these different things have will sort of lead us down the road of figuring out, you know, if it's the journal or if it's the, you know, whatever, it's the caching, whether that helps. And I think lots of people will be interested in this too.
Yeah. Would you suggest we use Firefly for this? Because currently we are doing it on Emperor.
Yeah, I would suggest Firefly over Emperor, yes.
Yeah. Cool. All right.
Cool.
Looks like we'll follow up with some of the suggestions, and we post some of the results out later on the email links.
Cool. Okay.
Cool. Does that cover everything you needed, Luke?
Yeah, I think so. We'll work on it, and we will come up with some results, and we'll share with you guys.
All right. Great.
Sounds great.
So,
All right. I think we'll move on to the next session then.
all right.
Which is a break.
A break. We just had
All
one.
right.